In the context of Brady's role as Chief Security Officer at Stack Corporation, he and his team must manage a multitude of sensitive areas across the company's OpenShift container platform environment. Everything from user privileges to access controls to capabilities that are enabled or disabled for applications and the services running on that environment. Up until now, we've been referring to these sensitive areas as protected Linux functions of the Linux operating system kernel, which is a useful term but also a rather generic one. In this section, we'll expand on exactly what these protected Linux functions are. They align with the privileges, access controls, and capabilities just mentioned earlier in this lab, and how exactly it is that the capabilities of SC Linux and CoreOS help secure these areas of the business for Brady and his CSO team. Protected Linux functions and permissions are requested by the containers via what is documented in security contexts or SC documents. They are categorized by three different types: privileges, access controls, and capabilities. Each type follows a unique set of rules and syntax, which helps to distinguish between each of the three at a quick glance of your pod's deployment manifest. The complete documentation on each of these three types is available from the Red Hat documentation pages online, should you wish to dig into any particular area more. However, so as to not be exhaustive in our coverage of the hands-on material, we'll be focusing primarily today on the variables and values that are commonly used for defining SCs, where permissions for protected Linux functions are requested, and for crafting SCCs, where administrators like Brady enable or disallow access to particular permissions. Privileges describe the general authorities granted to a pod and the containerized applications running within it once it has been deployed to an OpenShift cluster. Privileges are enabled by setting their value equal to true, either as part of an allowed privilege definition in an SCC or as part of a privilege request in an SC. Defining allowed privileges inside of an SCC set by Brady and the CSO's office is something that might look like what is on the documentation and the screen provided to you here. The first line specifies that the pod can run in containers with privileged processes running atop of it. The second line specifies that the child processes running on that pod can gain more privileges than its parent. In other words, it has the ability to elevate the privileges above those inherited from the parent process. Requesting that privileges be allocated to a pod set by Amy in the CIO's office as part of their SC's deployment manifest would look something like the following. As you can see within the SCC definition, the administrator Brady must be explicit in terms of the privileges that are to be granted. Within the SC definition, the developer, Amy, only needs to request that privileged access be enabled and set to true for her applications. One thing to note about enabling privileged containers and pods within an OpenShift cluster, or giving them the ability to escalate privileges after deployment, is that doing so inherently makes the environment and the cluster much less secure than it would be otherwise. In effect, a privileged container is capable of running processes and applications within it that are close to or even equivalent to the privilege levels of other processes running elsewhere on the container. Processes that might be vitally important to the management of the node or the pod that's running upon, or even to the overall cluster itself. You never want to create a situation where a pod whose job is to insulate the hosts from the containerized applications running within it is no longer able to protect the host by containing the process. A process with elevated permissions may find itself inadvertently or even maliciously hijacked, the effects of which could spill out across the overall cluster as a whole. It is far better and safer to ensure that the privileges of the containerized processes within a pod never match or exceed the privileges of the pod itself. Therefore, we often advise that to escalate container privileges only be done sparingly and only for well-trusted processes.